Hello, class. I'm going to show you how to do these problems that deal with areas of similar figures. You know what areas is? The number of square units inside something, or how much something covers something. Similar figures. Those are figures that have the same shape, but not necessarily the same size. So let's go to this problem. The figures below are similar. The labeled sides are corresponding. Okay? This rectangle has a side with 3 inches, and this rectangle has a side with 9 inches. Okay? 3 inches corresponds with 9 inches. As you can see, this is the shorter side of this rectangle, and this is the shorter side of this rectangle. Now, the area for this one is 24 square inches, and the area for this one, we don't know. So it asks us, what is the area of the larger rectangle? Okay, and I'm going to get this wrong. I'm going to put 12, which you know is wrong because it would be smaller than this one. How can this area be smaller than this one? Anyway, incorrect, of course. The correct answer is 216 square inches. So how did they do this? This is just a review of the problem. We don't have to read all that. So remember, this is the stuff you want to pay attention to. The following proportion applies to similar shapes. The quantity a over b squared is equal to a sub 1 over a sub 2, where a over b is the ratio of the corresponding side lengths, and a sub 1 over a sub 2 is the ratio of the areas. Okay? So here it says, find the square of the ratio of the corresponding side lengths. Okay? So a over b became 3 over 9, and they reduced that to 1/3, and 1/3 squared is 1 over 9. Okay, that's their way of doing it. You don't have to reduce, you can just square it. It'll still work. And it says find the ratio of the areas. A sub 1, which came from the smaller one, is 24, and a sub 2 is the one we don't know. And they left it like this. And I would have put x, but a sub 2 works. So they put these two ratios together. So use these two ratios to set up a proportion and solve for a sub 2. And that's what they did. They put this with this, and they got this. And then they solve. Okay? They did it this way. I would cross multiply, but both ways work. Both ways get you 216. And that's the area of the larger rectangle. Okay? So we're going to do this here. Now, before I get into this, I just have to remind you that there's more than a way to solve these problems. And sometimes you want to be on the lookout for certain things. And it looks like this one can save you some time. Okay? So let's go into this one. The figures below are similar. The labeled sides are corresponding. This one has 8 centimeters as a side, and this one has 5 centimeters. This area we don't know. This one is 25 square centimeters. It says, what is the area of the larger square? Okay, now, this is when you want to pay attention. They just want to know the area of this square. Now, a square, all the sides are the same. You know that. And a square is a parallelogram. And to find the area of a parallelogram, you just do base times height. Or in the case of square, you just take the side and you square it, 8 times 8. That's all you needed. You didn't need to know anything about this smaller square. You just need to know that in the area formula. So 8 times 8 is 64. Okay? You got to pay attention. See if you can find a shortcut. Okay, now this one. The figures below are similar. The labeled sides are corresponding. As you can see, 8 goes with 6. How do you know they're corresponding? Now, if you look here, 8 is the shortest side of this triangle. And on this triangle, 6 is the shortest side. Now, the area for the larger one is 64, and the area for the smaller one is unknown. We're going to look for that. It says, what is the area of the smaller triangle? Okay, so if we remembered from that explanation, you have to have that ratio of the corresponding sides. So here it's 8/6. Okay? And you have to square it. And like I said before, you don't have to reduce. I'm not. So 8 times 8 is 64. And 6 times 6 is 36. So there's our first ratio. I know there's a big numbers. It's better to work with smaller numbers, but you have your calculators. And I know some are using photo math. I'm not that dumb. Okay? Now our other ratio. The other ratio is the areas for the shapes, okay? 64 came from this, and its area is 64. Oh, I like these problems. 36 came from this one, and this area we don't know. Now, we don't have to cross multiply here because what's missing? 64 is the same as 64, 36 is the same as 36. Okay? And the answer is 36 square yards. The area of the smaller one is 36 square yards. There we go. Okay, here's another one. The figures below are similar. The labeled sides are corresponding. 1 foot, 2 feet. Area is 4 square feet. This one we don't know. What is the area of the larger rectangle? Okay, there's no shortcuts here. We need the height. We don't have it. So let's go about doing this. So the ratio. 1/2. So you need the ratio of the side lengths. And you square it. This cursor. Curse you, cursor. 1/2 times 1/2, or 1 times 1 is 1. 2 times 2 is 4. So there's our first ratio. It's the square. You take the side lengths, make a ratio, and you square it. Okay? And we got to match that with the areas. Okay? So I'm going to put that 1/4 here, and then I'm going to put the areas with it. So the 1 came from this, and its area is 4. The 4 came from here, and its area we don't know. Okay? So we're going to cross multiply. X times 1 is x. You can put 1x, but you don't have to. And 4 times 4 is 16. Okay? And so the area of this one is 16 square feet. Okay? Yeah, so that's basically how you do it. We'll give the corresponding sides, you make a ratio, you square it, and then you put the area ones together, cross multiply. And I'm going to get this wrong on purpose again because I want to get to, yeah. That's the walk. If you're hearing that stuff in the background, that's the walkie-talkie of the custodian of my building. All right, so you have to remember this. The following proportion applies to similar shapes. A over B squared is equal to A sub 1 over A sub 2, where A over B is the ratio of the corresponding side lengths. Okay? So you got to remember that proportion. All right, so you should be good with this. Good luck.